right, so let's begin our discussion about graphs and functions and being able to kind of go back and forth between function equation and function graphs by looking at one of the examples from our first lesson. So take a look over here at our canvas. And you'll see that I've set up a graph for us already. I have the equation y equals 2x plus 1 because we actually, you may or may not remember from lesson 1, but we actually created that equation by looking at the set of points 1, 3, 2, 5, 3, 7, 4, 9, and 5, 11. And the way that we created this equation up here is that we tried to see, like, okay, how would I make the input of 1 become the output of 3? We tried adding 2, but that didn't work as we went down the line. Adding 2 was not a great enough number. Like 2 plus 2 does not give us 5, it gives us 4. 3 plus 2 gives me only 5, not 7. 4 plus 2 gives me 6, not 9. So clearly the pattern is kind of outpacing me. It's not plus 2. We also tried multiplying by 3. 1 times 3 equals 3, but 2 times 3 equals 6, and 3 times 3 equals 9. So that pattern was too fast for us, basically. So the pattern 3, 5, 7, 9, it was growing too fast when I tried to multiply by 3. I didn't keep pace, again. So we tried multiplying by 2. 1 times 2 is 2, and then adding 1. Multiply by 2, you get 2. Add 1, you get 3. Multiply 2 by 2, you get 4, plus 1 equals 5. 3 times 2 is 6, plus 1 is 7, and so on. So that's how we created this equation, directly from a set of data points, or what we call ordered pairs, as we talked about in the last lesson. All right, so now I'd like us to take that information, and I'd like us to graph these ordered pairs on my xy axis over here. So starting with the point 1, 3, remember 1 defines the x coordinate and 3 defines the y coordinate. So this is going to tell me where I go left and right, and 3 is going to tell me where I go up and down. So because this is the x and this is the y axis. So using the coordinate 1, 3, and also noticing that these blue little hash marks are counting by 2, right? 2, 4, 6, 8, 10. So if I want to go 1, 3, I'm going to go from the center out 1, which is right here in the middle, and up 1, 2, 3. Over 1, up 3. And that's my data point. I'm going to do that, so let me check that off. 2, 5. Going to go, that means right 2, 1, 2, and up 5, 2, 4, 5. Again, I'm going to plot, oh, I should check that off, 3, 7. So that goes 1, 2, 3, and up to 7. 4, 9 means go over 4, up 9. And then last we have 5, 11. So 2, 4, 5, and that's 11 is right about there. Now if you notice, we have a visual pattern in the same way that we had a pattern of numbers here, 1, 2, 3, 4, 5, 3, 5, 7, 9, 11, which happen to be odd numbers counting up from 3. That is a pattern, a number pattern, but over here on the right we now see that those ordered pairs also make a nice visual pattern. And if we had a nice piece of graph paper where, because I know that we can't be exact here, but if we had a nice piece of graph paper, we'd be able to extend this line down. I'm trying to make it as straight as possible, which is easier said than done, but you can see the basic idea. This line would represent the equation y equals 2x plus 1. So now let's talk about that. Let's see if we can see any similarities between the information in this equation and the information that we see on this graph. in order to do that, I want us to point out the two important numbers in this equation. The number 2, which is the number that's multiplying x, and the number 1, which is the number we're kind of adding onto the end. So 2 is important and 1 is important. Why is it important? Well, I haven't told you yet, so no worries. But I am going to give you the hint that they are important. First of all, this number 1 is something that we call the y-intercept of an equation. And we'll think about what that means. Y is a variable which we have identified on the vertical axis, the up and down axis, and then intercept means to make contact with. So if you think about football, right? If there's an interception, it means that one team comes in and grabs the ball from the other team. There's contact between team 1 and team 2. So intercept, a y-intercept, means that there is contact between the equation and the y-axis. And that happens right here. This is the point of contact. Or in other words, it's the y-intercept. And what I want you to notice is that the number 1 up in our equation, my little arrow, the number 1, is the same as the 1 position on the y-axis. And that is, of course, not by accident. That is how the y-intercept works. So the equation, y equals some number times x plus some other number, that last number is going to be the y-intercept, physically speaking, on the graph. We'll talk more about that in a moment. Now the other important number here is 2. Again, this information I'm not going into extreme detail because this is stuff that you should have gone over before in Algebra 1. But I want to make sure that we at least give a cursory overview so that it all comes back. If you have further questions, those are great notes to jot down in your notes right now to say, Mrs. Stein, I need a little bit of review on this. Okay, so number 2, why is that important? Well, number 2 is what we call the slope. The slope is always the number that's multiplying x. So it's the number right before x. In this case, obviously, 2. And remember, the slope is how steep a graph is. So I'm going to come back here to my video. If we have a graph, if you think of my arm as representing a line, we can make a line that's really steep. We can make a line that's really shallow. We could even make a line that's flat, straight across. We could make a line that's kind of in between, like not really steep, not really shallow, but kind of in between. That actually, we can even make the slope go down, right? So instead of going up, it could go down. So if you think of this as climbing up, or actually what we call a positive slope, that's material we'll get into a little bit more in these videos, but positive slope means that it's going up. We can also even turn the line so far that now the slope is going down. And we're always reading from left to right, or we're reading in math the same way we read in English. We move from left to right. So if from left to right it is getting higher, that means that it's growing, it's positive. If from left to right it's getting lower, that means it's negative, it's going down. I can't say that it's less steep, but it's what we would call a negative slope. So thinking about that's our meaning of slope, look back at our graph here. So where do we visualize? The y-intercept is easy to visualize on the graph. It's the point of contact between the graph, or the line of the graph, and the y-axis. Where is the slope? How do we visualize the slope? Well, if you recall from Algebra 1, the slope, we see it in the climb of from one point to another point. So in this graph, I go up 1, 2, and over 1. Up 1, 2, over 1. We go up 1, 2, over 1. Up 1, 2, over 1. Whoa. Up 1, 2, over 1. So I've made some stairs here. Hopefully this looks familiar. And I'm counting by how many units I go up and how many units I go over. So right now I'm going up 2 over 1. And that is where we can visualize the slope. Slope is, if you remember, usually represented by the letter m. and we call it the rise over the run. I'm actually going to write more of this down because I want to write more on the bottom. So I'll say slope is often described by the letter m. We also call it the rise over the run. We also call it the change in the y variable over the change in the x variable. That symbol, the triangle symbol, is a delta symbol. It represents change. Or another way of writing it is y2 minus y1 over x2 minus x1. We'll talk more about that in one of the continuing videos from here. You might want to, actually you should, in your notes, write this formula down. We're going to talk about it later, but right now I want to think about it in terms of this first definition, that slope is the rise of a graph over the run. So rise is what's happening in a vertical faction, in a vertical part of the graph, and then run is what's happening horizontally. So looking at our information here, our rise is 2 because we're going up 2. Our run is 1 because it's going over 1. And again, what I mean by that is in order to get from one point to the next point, I have to rise 2 and run 1. So in this case, the slope is rise, which is 2, over run, which is 1. And what is 2 over 1? Just 2. Where did we see that number before? Well, right up here in our equation. So, quick review here. We've now shown that these data points over on the left, over here, we have 5 of them. We were able to look at that pattern and create an equation. When we plotted those points and looked at them as a pattern visually, we found that the information on the graph also reflected our equation in the sense that the first number, the number that's multiplying x, is what we call the slope, which I'll just call m right now, and the 1 that was being added is what we call the y-intercept, which actually we usually use the letter b to talk about that, and here's why. If you recall, one of our most important equations when it comes to graphing is y equals mx plus b. What does that mean? Well, y is just y, x is just x. We mostly ignore them and let them be. They just represent our input and output variables. But m represents our slope, b represents our y-intercept. Just like over here. 2 represents our slope, 1 represents our y-intercept. So take some time. You might even want to pause the screen here. Make sure that all this information is written down in your notes. And then in the next video, we're going to look at a couple more examples. But instead of graphing using data points, we're going to actually try to graph straight from an equation.